So today we're going to talk about molar mass, and I want to do an example for you and also show you how to set up your notebook for this assignment. Our objective for this assignment is to calculate molar mass using a chemical formula. In your own notebook, if you prefer, you could just start with the verb, which is the word calculate. But I do think it is helpful to have the objective in your notebook because that tells you exactly what you're going to see on this page. I usually, for myself, also like to put the date. So today is November 6th. And this is how I set up my notebook, even for classes that I still take as an adult. I think writing helps you learn. If you prefer to use an electronic document for this, that is an option, but just remember if you're going to use resources on an assessment, they would need to be resources in a notebook. So students will calculate molar mass using a chemical formula. In the assignment, the example I gave is H2O. Okay? And we should know by now that when we look at a formula like H2O, that means there are 2 atoms of hydrogen and 1 atom of oxygen. Okay. We also learned that to calculate atomic mass or mass number, we add up the number of protons and neutrons in an atom. For these problems, you can use the atomic mass that's listed in the periodic table. We'll talk more later about why that atomic mass in the periodic table is slightly different than the mass you would get by adding the protons and neutrons. It is still based on that concept, and there's sort of a complicated reason why it's slightly different. But we'll use the atomic mass that's listed in the periodic table because that's a resource that you can use. And I would give you a periodic table on any assessment. So we need to find the atomic mass of hydrogen. I have a periodic table below the paper here. So if we take a look, you'll need to use one that you can find on the internet. And if you look at hydrogen up here in the corner, remember that the number below the element is the atomic mass. For our purposes, we can just use 2 decimal places. So instead of all of those numbers, I'm going to write 1.01 for hydrogen. And then for oxygen, again, we can use 15.99 or even 16.0 if you round up, right? That slight difference is not going to make a big difference in our calculation. Okay, let's make sure this is easy for you to see. Okay, so below each element, I wrote the atomic mass, and then the number that I got from the formula, the 2 hydrogens, I need to multiply by that first number. And then here I can multiply by 1, but since I'll get the same answer, it's not necessary. If I'll multiply 2 times 1.01, I'll get 2.02. So 2 atoms of hydrogen would have an approximate atomic mass of 2.02. And 1 atom of oxygen is 15.99. And then I need to add those together. I would get 18.01. Okay, so the molar mass for a molecule of H2O would be 18.01. And we're going to use the units grams from now on. And we'll talk about why we use grams when we're talking about molar mass. But we're going to start just by practicing to calculate that. Okay, so instead of using atomic mass units, which would represent an individual atom, we're going to use grams, which represents what's called a mole of atoms. Okay, we'll talk more about what the mole means later. But that is the basic calculation. And then I want you to do the other 3 problems below that one in your notebook and then take a picture and upload it for me. Thank you.